y'all ever heard of the word cryptography before? Cryptography. So put yes or no in the chat. Have you ever heard of cryptography? Okay, cool, cool. All right. I actually had to take a whole class on cryptography, you guys, when I was in grad school. A whole class. All right. But modern cryptography, and I'm just reading off the notes, modern cryptography intersects the disciplines of mathematics, computer science, and engineering. Applications of cryptography include ATM cards, computer passwords, and electronic commerce. Cryptography is the science of making and breaking code. And perhaps y'all seen movies about this, but you didn't realize exactly what you were looking at. But there are movies about people back in the day making and breaking code. Until modern times, cryptography referred almost exclusively to encryption, which is the process of converting ordinary information or plain text into unintelligible gibberish called ciphertext. Decryption is the reverse. In other words, moving from the unintelligible ciphertext back to plain text. So, what would be a field or area in life where they may be able to use this concentration, cryptography, breaking codes, making codes? What field? Zoe.
Maybe like digital forensics or like cyber security, something like that, or management.
Oh, very nice. Cybersecurity. Yes, very nice. All right. But and if you look above, it says application of cryptography include ATM cards, computer passwords, electronic commerce. To me, that fits into that cybersecurity, keeping people out of certain systems that have information in them, uh, so that they're not hacked, for example. Give me something else. Cybersecurity, something else where you're trying to shield information or you're trying to figure out information. Give me another field maybe that could have used codes, breaking codes. There's one more field I'm thinking about.
App installers,
What is it, Kenneth?
like app entrepreneurs.
Okay, apps and stuff. Okay, I can see that. I can see that. You can do anything with apps these days. They have an app for that. Whatever, whatever you want, they have an app for that. People make a lot of money with these apps too, and that's one thing I wish that I could do more of is uh, program so that I could, because you can make money. All you have to do is create an app, and you probably get so much money per download. But what I was thinking about was military, right? When people were at war and they wanted to send messages to each other without the enemy knowing, they could put it in a code so that the enemy could not figure out what the code was. All right. Only the person that you're sending it to would know what they call the key to that code. For example, would you be able to decode the following message without a clue? And I'm talking about this right here. If I didn't give you a clue of how to decode it, could you decode it? It's actually a sentence. It's a sentence, but could you decode it? And I'll give you 30 seconds to look at it to see what you think. But it'll be very hard if I didn't give you the key to it. Any guesses? All right. Pretty much what my other class did too. They're like, I don't know what that is. It got an ES, UIP. It's gibberish, right? It's right now it's gibberish. It's It's not in the English, the normal English language that we know of, but it's a code for something. Now, what if I gave you the key is, I'm gonna tell you what the key is. The key is, make it red, shift every letter once in the alphabet. Shift every letter once in the alphabet. So I'm giving you a clue or the key to how to decode this message. Does that help in any way?
It kind of does.
Okay, did you come up with anything?
So far, I came up with FR, but I don't know if it's right.
FR. But it doesn't spell anything. So that's not right.
Yeah, not yet. I
Or
guess when you
it
do
doesn't mean anything. So each space, see, each space means something. Like it could be a word or it could be something else. Kenneth, what you think?
Oh no, ma'am.
Okay, you just
I
have it, your microphone on. Okay. Anybody else? I'm gonna give you about 20 seconds to look at it. I gave you a key. Shift every letter once in the alphabet.
what you mean by shift though? Like,
Hmm.
Is we
Let's see what I
shifting
mean
to
by.
the right or to the left?
Oh, good question, Alicia. Good question. I'm not telling you. But good question, Alicia. You're on to something now. Now, what would be helpful to do before you decide? What would be helpful if you did what right now?
Maybe if we think about like the alphabets and
Thank
I
you.
don't know.
Thank you, Alicia. How many letters are there in the alphabet?
And it's
26.
20.
26.
26.
26.
Wouldn't it be helpful to write all the alphabets down for a second?
That's what I just did. Then I shifted to the left, and then I shifted to the right, and it's still not kind of making sense because I got FR, then I got D, V, and
Hmm. Okay. Anybody? All right, y'all. Y'all got to get it now because the other class figured it out. The other class figured it out. So I'm counting on y'all. Not a clue yet? Anything? No? Okay. I can't stay here forever. Akira, what do you think?
Give me one. You can go ahead.
Okay. All right. So shift every letter once in the alphabet. So each one of these letters is the letter before. So what's the letter before E?
D.
All right. What about S?
R.
R.
R. All right. What about U? What's the letter in front of U?
T. Dr.
All
Thomas.
right. What about? Yeah. Okay. Thank you, Dr.
Is it
Thomas.
Dr. Thomas? Is the
Oh, okay.
um greatest?
Instructor.
Thank you for that. I appreciate you saying that about me. All right. All right, very good. We finally figured it out. All right. So that's just an example of one basic way to encode something. It's just shifting the letters in the alphabet. But in this lesson, we're gonna use math, advanced math, to do encoding and decoding messages. But we gotta learn some things first, okay? We gotta learn about inverse functions before we get all deep into this. So by the end of this lesson, you will be able to decode the following message. Look at this. This is totally different. Now it's numbers. All right. So That's an example of how we're going to use math to come up with our own messages and decode messages. But let's go to the basics of this week's lesson, which is one-to-one, a one-to-one function. All right, a function f of x is a one-to-one function if x values do not share the same y values. All right, if x values do not share the same y values. So that kind of reminds you of what a function is. I think the function is reversed. If y values do not share the same x values. I don't know if y'all remember that, but to determine if it's a function, it's the opposite. You don't want your y values to share the same x values. All right, let's move down to this graph here. All right, first, let's determine if it's a function first. Can you tell me if this graph is a function? It's in green right here. Is
Yeah.
it a function?
Yes.
Okay, good. What type of function is it?
Linear.
Very nice. This is a linear function. So, all right. And how did you know right off the bat, from what you learned in class, that this is a function?
Because of the y-axis.
Okay, you
It
say
don't touch
y-axis,
the
but what
line.
I want you to say it again, Zoe.
Oh, it only touched the line one time, the straight line, like the horizontal line one time. Again. The
Not
red.
horizontal line.
The symmetry is it some with symmetry?
All right. How did we determine if a graph was a function? Alicia, by the what?
If it touches the
Yes,
y-axis more than
Ashley.
one. Oh,
Ashley said the vertical line test. Y'all remember that? Vertical line test? The vertical line test told us, and Lakira was saying the y. I knew what she was talking about, but I didn't want y'all to say go with the y-axis. I want you to just say a vertical line test. So it doesn't have to necessarily be the y-axis. All right. Now that we know that it is a function, we can determine whether it is a one-to-one function. This is some more specific. It's one-to-one if it passes the horizontal line test. All right. Does it pass the horizontal line test? That's why there's a maroon line here. See that horizontal line? Does it pass the horizontal line test? Yes or no?
Yes.
Yes. It passes the horizontal line test. All right. So, function, yes, it is a function. Is it a one-to-one function? And I might abbreviate it like this. I might put a little notation like this. Is it a one-to-one function? If it passes the horizontal line test, yes, it is a one-to-one function. All right. Let's look over to the right over here. Is it a function?
yes.
Yes.
All right. By which test do we know it
Quadratic
is a function?
function.
The vertical line test.
The vertical line test. All right. It is a quadratic. Somebody already said this is a quadratic function. All right. So it is a function. We even know it's a quadratic function. We even specify what type. Is it one-to-one though?
No.
No, it is not one-to-one. It's hitting, and as you can see, it's hitting the graph twice. All right, using the horizontal line test. All right. Why is it important that we know it's one-to-one? If it's one-to-one, then we know that it has an inverse function. If it's not one-to-one, it doesn't have an inverse that's a function. And we'll talk about that a little later. All right, here we go. Again, why are one-to-one functions important? One-to-one functions have inverse functions. We're very interested in this concept called inverse functions, especially when it comes to encoding and decoding, because we're basically just doing the reverse to figure out what the messages are. All right, here we go. Let's start by looking at points on the graph. We have the point 47 right here, and its inverse is 7, 4. All right. We also have the point -5, 3. Its inverse is 3, -5. Tell me, what's the pattern here? 4, 7, 7, 4, -5, 3, and 3, -5.
They flipping it.
They're
Exactly.
flipped.
Yep, they're just flipped. The inverses are just the flipped numbers. All right, so the inverse of 4, 7 is 7, 4. We're just flipping x and y. We are interchanging x and y. So you might see that word coming up soon. Interchanging x and y, or flipping x and y. All right, let's look at this. Inverse functions are symmetric about the line y equals x. All right, here we go with that phrasing again in math. Symmetric about the line y equals x. All right, let's look at this graph right here. This line here in purple, that is the line y equals x. Recall it from what you had to learn for test 1. What type of function did we call that? When you had to learn it for test 1, you saw you had some semi-guided notes and you had all the graphs on there. What type of function is y equals x? Very specifically, what was it called? Anybody remember?
Is it absolute?
Say it again.
Is it absolute value function?
Just that purple line right there, not the other ones, not the red or the blue.
Okay.
Is it
What y'all think?
It's not a constant
identity
function.
function?
Identity. Very good. Identity is the one that goes straight like that. It's that purple line. It's called the identity function. All right, very good. And the other one, the other linear one was called constant. Somebody said that. But this one right here, this purple one, is called the identity function. All right, very good. Identity. So more specifically, it's called the identity function. All right, notice if you folded this red and this blue across this, wouldn't it be symmetric? If you
Yes.
folded across. All right, good. That's all it means when they say symmetric about the line. If you folded it across this line in the middle, y equals x, then it'll be like a mirror image of itself. That's all it means. So if that happens, you know that they are inverses of each other. So this line here in red is the inverse of, not the line, but this little function here in red is the inverse of this function here in blue. They are inverses, and proof is they are symmetric about the line y equals x. Now let's do our own little graphing over here on the right. Sketch the graphs of the inverse function f of x equals x squared plus 1, and that's when x is greater than or equal to 0. And, all right, this is new notation for you all, this right here. It looks a little different. It does not mean to the -1 power, believe it or not. I know that's what we learned in intermediate algebra. It's just the notation for inverse function. All right, notation for inverse function. This right here. It's just notation. For the inverse function is the square root of x minus 1. All right, we're going to graph both. I'm going to squeeze it in here some kind of way. So I guess I'll graph f of x equals, let's do this in black. F of x equals x squared plus 1, but when x is greater than or equal to 0. So let's do a little t-table. x and f of x. All right, we're going to graph this. Tell me, what type of function is this? This x squared plus 1.
Quadratic.
Very nice. What does it look like? What type of shape?
A
A
U.
U.
Very good. It's going to be a piece of a U, it's sort of like a piecewise function because they only want us to graph it when x is greater than or equal to 0. So on my table, where should we begin? What x value should we start with?
0.
0.
Yep. What other numbers would work? 0,
1,
1.
2, or 3.
Yep. You said what else you said, Dakiri?
2 and 3.
2 and 3 would work. Yeah, we needed more than 2 points because it's not a line. So we need to kind of figure out where it curves and things like that. So this is good. Started with 0. If you plug in 0 into this function, what would you get for f of 0?
1.
Very good. 1. Because 0 squared is 0 plus 1. What about if you plug in 1 into this function?
2.
2.
Good, because 1 squared is 1. 1 plus 1 is 2. What about 2?
5.
5. Very good. Because 2 squared is 4. 4 plus 1 is 5. What about 3?
10.
10. Nice. 3 squared is 9. Plus 1 is 10. So let's go ahead and plot this. We already know what it's supposed to kind of look like in our heads. That's important that you know before you start graphing. 0, 1. Because if it's not going in a direction, we know we didn't do something right. 0, 1. Where do I plot 0, 1? Someone other than Alicia, Kenneth, and Akiria.
Go to
0. Okay.
the and then go up 1.
All right. Just go up 1, right?
Yes, ma'am.
All right. What about 1, 2? Somebody else other than Zoe, Alicia, Kenneth, and Akiria. All right. Other than,
Don't you
okay,
go to
right.
the right one up too?
Right 1, up 2. All right. I want you to be more confident, Raven.
I
You
be
asking
thinking
me,
they're wrong
don't
though. I
you?
don't know.
That's all right. It'll be wrong. It'll be okay. But that's what we do. We here for learn. All right. 2, 5. 2, 5.
Right 2 up 5.
All right. Right 2, up 5. 1, 2, 3, 4, 5. I'm seeing my curve. And since 310 is off the graph, I'm just gonna stop there. Y'all see the curve that we want here? Doing
Yes.
that curve. And we kind of learn about transformations, and because it's plus 1, we kind of knew that it was going to shift up 1 from the original parabola anyway. So all of that information helps us when we're graphing. All right, let's graph the inverse function now. All right, we're going to graph the inverse function. So I'm going to put it over here. F of, I'm just going to say, let's just call this inverse function, because I was about to say f of -1, but I don't want to say that. This is the inverse function again, equals the square root of x minus 1. Notice they want us to figure out what we can plug in. What is the domain? Uh-oh. One of those concepts we're going to continue to hear about. What is the domain of this inverse function? So domain of a function means what numbers can we plug in to this one? Basically, that's what domain is. What x values can we plug in here?
You can start with 1.
You sure can. You can start with 1. What give me something else?
0.
Can we plug in 0?
It has to be greater than 1.
It gotta be greater than or equal to 1. That's the domain. All real.
So you could just use 2, 3, 4, 5.
2.
Okay. Okay. Because if we plug in 1, it will be, y'all see, it will be a negative number under the radical. Y'all see that?
Yeah.
That square root. So that would be a problem. Now, what's the shape of this graph before we even start graphing? What's the shape?
It curves to the side.
Yep, it does. It curves to the side. All right. So we plug in 1. The square root of 1 minus 1 is what? Let's plug in 1.
0.
1.
0, 0, because square root of 1 minus 1 is the square root of 0, correct? Which is
Yes.
0. What about 2? The square root of 2 minus 1
1.
is 1. What about 3? Uh-oh, I'm going to get y'all on this one. What about
2.
3? What is it?
Is it 2?
Not exactly. What is it? Square root of 2, which is equivalent to what? Y'all give me a decimal for that.
1.4.
Is it 1.4? Thank you.
Yeah.
All right. It probably would have been best if we skipped 3, to be honest with you, and substitute a wet x value. You think? Skip 3 and go to something that will work out nicely in the end. What number can we plug in that probably would have worked out?
5.
9.
5. Yep, 5. Because then it would be square root of 4. Y'all see it? All right. Then it would have been 2. That would have worked out nicely. All right, let's plot some points. 1, 0. Put that here. 2, 1 here. And I think the key already told me it's gonna kind of go off to the side. So if you want to plot 3, 1.4, great. I'll put a little dot right there. Y'all probably can't see it, but I tried. Hold on. I might have to. I'm trying to erase it. All right, 5, 2, somewhere along here. So he's doing this. All right, good. Those are the two. Do you think they are inverses of each other just from the graph? Just from the graph.
Yes.
Yes.
Yep, because they are symmetric about the line what? Symmetric about the line.
Y
Is it
equals
x squared
X.
plus 1?
Y equals X. Again, to figure it out, can you fold that black and blue across this line right here? It will never change. If you can fold it across this and it's symmetric, then you can tell they are inverses of each other. All right. So that's the line you're looking for if you are looking at the graphs to determine whether they are inverses of each other. But we already told you they were inverses, but I wanted to show you that that's another example. All right. Let's talk about the horizontal line test. Let's practice talking about functions and inverse functions again. If horizontal lines intersect the graph of a function in at most one point, then f is 1 to 1. Use the graph to determine whether the function is 1 to 1. Let's first determine, again, just practicing over and over again. Is this function here? I didn't mean to say that. Is this a function? Is this a function?
Yes.
Yes.
Yes, it is. So I'm put function question mark. Yes. All right. And what type of function is it? Just asking these questions.
Quadratic.
Right.
All right. Very good. Is it a one-to-one function though?
No.
No.
No. Because how do you know?
The line at the bottom is the
Test.
graph twice.
All right, Kenneth, you looking at the axis of here. Well, what did you say?
The horizontal line test.
Yep, it does not pass this horizontal line test. So if you just draw an imaginary horizontal line anywhere on this graph, it's gonna hit it twice. So that's how you know. So You don't necessarily have to look at the axis. You just draw an imaginary one in your head or just draw one on your paper. All right, let's look at this one over here. Is it a function?
Yes.
Yes, it is. Is it one to one?
Mm,
No.
no.
Yes, it is.
Yes.
Ah,
Yes, it
trick
is.
you. Yes.
Hmm.
All right. If you draw a horizontal line, it's only going to hit that blue graph once, correct?
Yep.
See, they try to trick you with the two lines right there. All right. Since it's one to one, then it has an inverse function. Since this is a or in one to one, is it a one to one function or a in one to one? I gotta look that one up. Y'all,
Hey,
English people, where are
It would
you?
I
be
think
hey,
it's
18.
an A.
no,
I say
Because
I
it'd
thought
be
it was.
a,
18 because it's a vowel. You got a vowel right there in one. That's why I see it wrong. I may be wrong.
you think it's what, Zoe?
A-N.
We're debating. Half the class like is A in, and the other half like no, it's A.
Cause my phone be correcting me, so that's why I know. But I was taught. That's what I was taught. Like when you have another vowel, I thought it was supposed to be A-N. If you get
All
I just
right.
put whichever sound better.
Well,
Same.
here's what I think. I think the rule is if you say the word and it doesn't sound like a vowel, for example, one, doesn't that sound like W? Y'all get what I'm
Oh
saying?
yeah,
One.
yeah, yeah, yeah.
So you use A for that one. Now, if it was like hour, even though it starts with H, you put A in. Y'all get what I'm saying? Even though it started with an H, we use A in. English, y'all, I bet that's a hard language to learn. I'm so glad I just know it from birth. But I bet for other people, I bet they're like, what type of rules did they make up in English? All right, because I bet it's hard to learn English. All right, since this is a one-to-one function, then it has an inverse. So here's the one that I actually use a in because it's in. You can kind of like you're saying like that e sound inverse and inverse function. All right, very good. Let's go to this one. Is this one a function?
Yes.
Yes.
Yes. Is it a one-to-one function?
Yes.
Yes, both. All right. It passes both the vertical and horizontal line test, so it is the graph of a function that has an inverse, which is also a function. Very good. Is this one a function?
Yes.
Yes. Is it a one-to-one function?
No.
No.
No. All right. It passes the vertical line test, but not the horizontal. And so it is the graph of a function, but it does not have an inverse that is a function. All right. What about this one? Function?
Yes.
Yes.
Yes. Is it one to one?
No.
No. It passes the vertical line test, but not the horizontal line test. Therefore, it is the graph of a function, but this function does not have an inverse that is also a function. Is this a function?
No.
No.
No. So we don't even care if we don't even apply the horizontal line test for the inverse because it's not even a function to begin with. All right. So no, not a function. So we do not apply the horizontal line test. All right. Let's look at this one. I'm going to give you 60 seconds to write down, first of all, is it a function? And then, so do both of these. Determine if it's a function first, and then determine if it's a one-to-one function. So just write it down for now, and then we will come together with the answers. right. Is this first one a function?
Yes.
Yes. Yes, it is a function. Is it a one-to-one function?
No.
Yes.
No.
But not a one-to-one function. How did you know that, Kenna, that is not one-to-one again?
Because it's crossing more than one point along the horizontal line.
All right, and y'all can kind of see that pink is showing you the horizontal line that's testing it out. All right, and they're kind of pointing out, y'all see how we got all of these same Y's, but it's going to all these different X's. So it does not pass the horizontal line test. What about the graph on the right? Is it a function?
No.
No.
All right, not a function. So there is no need to apply the horizontal line test. It's not even a function to start with, so we don't have to figure out if it's an inverse function. All right. The graph of an inverse of a function. Let's look at these two graphs. One is in blue and one is in red. Just from the blue and red graphs, do you think they are inverses of each other? Based on what we learned about symmetric, about the line y equals x?
Yes.
Yes.
Yes. Okay, very good. They put in green the line y equals x. All right. Let's look at these points. These are the points on the blue graph. -2, 6. Let me see where that is. -2, -6, -2, -6, probably right here. Right here. All right. -1, 1, -1, 1. Somewhere over here, probably around here somewhere. 0, 2. 0, 2 looks like it's probably right here. Oh, that's -1, 1 right here. -1, 1 right here. 0, 2 right here. All right. 1, 3. 1, 3. All right. Somewhere around here. 2, 10, probably somewhere around here. All right. Let's look at the graph in red. These are the points. We got -6, -2. 1, -1. 2, 0, 3, 1, and 10, 2. If you compare the two, what's the only thing they did?
Switch the domain and range.
Yeah, they basically
That's
sweet.
very good. You switch the domain of range, or in layman's terms, all they did was flip what? Or interchange the what and the what?
The point, the X and the Y.
The Y and
The
the Y.
X and the Y. That's all they did. They just changed the X and Y. They just interchanged the X and Y. -2, -6 became -6, -2. -1, 1 became 1, -1. Y'all see it? All right.
Yes.
All right. So if I gave you this graph over here to the right, y equals 2x. Let's first of all think about, is it a function? Is that a function?
Yes.
How do you know it's a function? Let's go over. I know I'm repeating myself, but how do we know it's a function?
It passes the vertical line test.
Very good. It does. We know this is what type of function?
A linear.
Yep, it's linear. Y'all know how linear functions look now. And even if I just gave you y equals 2x plus 1, how do you know it's linear?
By the
The
degree.
exponent.
Yeah.
All right. The highest exponent is
1.
1.
1. How you know it's linear? When the highest exponent is 2, it would have been a what type of function?
Quad.
Quadratic.
Quadratic. If the highest was 3, it would have been a what type of function?
Cubic.
Q.
Cubic. Very good. Y'all doing excellent. Now that we know it's a function, let's determine if it has an inverse function. And or in other words, does it pass the horizontal line test?
Yes.
Yes. Because it passes the horizontal line test, we know that it is 1-to-1. All right, let me write this down. Because it passes the horizontal line test, this function is also a 1-to-1 function, and therefore has an inverse that's a function. All right. So we're going to use the information that we learned on this graph on the left over here and kind of cheat to graph our line over to the right, our inverse. So how can we use the information we learned over here on the left to graph the inverse of this blue line we have over here? What can we do to graph the inverse of this blue line?
You would switch the coordinates of the points.
Very good. All right, someone other than Kenneth, give me 1 point on this blue line.
You got 1, 3.
Very nice. I don't know who said that. Who said that?
Alicia.
Alicia. All right. Someone other than Alicia and Kenneth, tell me what is the inverse of 1, 3?
3,
What is
1.
the inverse? Say it again, Zoe.
Would it be 3, 1?
3, 1. Let me do another color here. 3, 1. So 3, 1. Plot that here. Yeah, make sure I'm plotting in the right spot. All right. Someone else give me another point on the blue function. The blue function.
It's
0,
1
1.
negative
0, 1. Okay, give me the inverse of that.
1, 0.
1, 0. Very nice. 1, 0. Okay. Someone other than Zoe, Nakiria, Kenneth, Alicia, and whoever else said something, will give me another point on this blue line here.
Okay, is it -2 or -3? I could be wrong. I'm probably
Yep.
wrong.
Raven, here you go again. We're going to have to build this confidence up. -2, -3. All right. What is the inverse, someone else, of -2, -3? Inverse. Come on, y'all.
-3,
Come on.
-2.
I know you know. I know you're like, oh, I don't want to say anything. -3, -2. All right. So right here, maybe. Okay. I'm gonna try to do my best to draw a straight line. I don't know though. See, I missed the whole point. All right, here we go. Okay. That's okay. All right, that's good enough. All right, does it look like it's symmetric about the line y equals x?
Yes.
So
Yes.
I tried my best, y'all. I tried to make it work. All right, but yes, it does. All right, so again, if you folded that across that line, it should kind of match up. That's what we're saying about symmetry, symmetric about that line. Very good. Let's move on. I think y'all getting it. All right, the inverse of a function. One functions are important because they are precisely the functions that possess inverse functions. All right, functions f and g are inverses of each other, provided f of g of x equals x and g of f of x equals x. So this is a way to prove that functions are inverses of each other. Way to prove functions are inverses of each other? Other than graphing it, of course, because we just graphed it and you just saw that they are inverses of each other, for example. But I may ask you to, or tell you to show that each function is the inverse of the other. So I might want you to do some algebra for me to show me that they are inverses of each other. How do you show me? You would do this right here and this. Now, what was this called back in the last section?
The FOG, or you said it wasn't an O, but it
Oh,
looks like a O.
Yeah,
Yep.
what was the concept called? What was the title of the concept? What was it? Started with a C.
Composition,
Composition.
composition.
Yep. Compositions or composite functions. Composite functions, maybe. So that's why we had to learn it in the last section because it shows us back up in this section. All right. So we gotta have to do this part, f of g of x, and it needs to pop out an x, and then we need to do g of f of x, the inverse. And if it pops out x2, then we have proven that f and g are inverses of each other. All right, let me show you. Let's start with the first direction. F of g of x. All right, let's do this. Here's your f of x right here. This is f of x. And your g of x is over here. All right. So if I just wrote down f of g of x, what do I put inside the parentheses first?
X plus 7.
6 plus 7 over 4.
Very nice. X plus 7, x plus 7 over 4, because we on the inside function is the g function. So I just replaced the g with what it is equal to, which is x plus 7 over 4. All right, next step. Anybody tell me what happens now?
it equals what
Then
x
you
now?
gotta
You gotta plug in something. Okay, what we plugging in?
plugging in 4 parentheses x plus 7 over 4 minus 7.
Very nice. All right, we are replacing the x in the f function with x plus 7 over 4. All right, so this x is being replaced with what's inside of the parentheses. X plus 7 over 4. All right, someone other than Kenneth tell me, how can we clean this up now? What can we do to
Multiply,
clean it?
You'll
multiply both
cancel
out
out.
both sides, and you can cancel them out.
All right, Zoe said something about multiplying,
I
and
think you
Alicia
can cancel it
said,
out.
You can just
yeah,
cancel
you
them
You
do
can
out
it.
cancel them out.
Just go
because
ahead and cancel them out.
Yeah.
Yep, let's
yeah,
just do that. Yep, because 4 divided by 4 is 1, so it cancels out, leaving us with just x plus 7, then writing down that minus 7 here. All right, someone other than Kenneth, Alicia, and Zoe tell me what happens next. What happens next to clean this up? What's our final answer, basically? All right, someone other than Zoe, Alicia, and Kenneth. Monisha.
Would you zero?
Would you do
It's be
what?
X, right?
It'll be X because
7 minus 7 is 0.
very nice. 7 minus 7 cancels out. So we get X. All right. We got it one way. We're not done yet, because now what we have to do on the other side over here? We also have to do what?
g of x.
G of what?
F of X.
F of X. All right. G of F of X. All right. So g of what? Someone other than Nakiria. G of what? G of f of x equals g of what?
4x minus 7.
Very nice. 4x minus 7. That's what f of x is equal to. That's the inside function. All right, next. What are we doing now? We got g of 4x minus 7. What are we doing with that?
You gotta plug it into the x.
Of what?
X plus 7/4.
Very good. This x right here got to be replaced. All right, so you can probably write down your plus 7/4, but realizing you have to replace that x with 4x minus 7. All right, someone other than Kenneth, what happens now? What would you do next?
Your 4s will cancel out and the 7s will cancel out, leaving you with x.
What should we do first, though? What's the first thing you do first? Which one you said both steps, but which one should go first?
The 4.
The 4.
Mm-mm.
You could just do -7 plus 7, which is gonna give you 0.
Yeah, you do this
Put
first.
over 4.
Yeah, you got to do that first because then that'll be cleaner like this, right? Or else really you're supposed to divide all of these terms by 4, and we don't want to do that. Let's get rid of this -7 plus 7 first. Then y'all see what happens. What happens next?
Left with x.
The 4's cancel.
Yep, the 4's count.
Let's cancel the for you.
Yep. So that's what I'm looking for, whether you can show that each function is the inverse of the other by doing the compositions. So now we know that f and g are inverses of each other.
Dr. Thomas, I got a question.
Yes.
So when we're doing this and we get different answers, then we did something wrong. Like they will always be the same.
Yes.
We're looking for the
Very good observation. If I said show that each function is the inverse of each other, I'm telling you it should come out to be x. And if you didn't get x, you know you did something wrong. Because I'm telling you they are inverses. I just want you to show it to me. Y'all get what I'm saying? I'm telling you these are inverses. I just want to see the algebra. I just want to see you work it out so that you prove it. Prove that they are inverses. But I'm telling you, if I say show that each function is the inverse of the other. Yep.
So will
Very
you let
good.
us show you like that, Dr. Thomas? Like if you was to give us a problem, like each step by step in Blackboard, or
Yeah.
how would you do that?
I know Weber sign. I got a couple problems out there where you have to put. You see
Well,
how
I
I got
filled in the blank with those.
What'd you say, Alicia?
I was saying I filled in the blank, the homework assignment.
Yeah.
I just had to fill in the blank with.
Yeah, I'm gonna have to figure that out for the test. Alicia, I'm about to figure that out. I don't know whether I'm gonna require you to take a picture of it or something. I don't know yet. Or I may not. I may just give you answer choices until you tell me which one is worked out right. I haven't figured that part out yet. But Weber sign, you are required to kind of input things inside of something. And y'all see what I mean. A couple of problems like that on your homework. All right.
Yeah.
You just make sure you understand it, and I'll figure out this test. I don't know how I'm gonna do it.
Okay.
All right. Yeah, I'm still used to face-to-face classes at this point, but we're working it out. We're working it out. All right. So we're gonna skip that little part again. We got one little thing to cover, and we're not going to finish. Do y'all hear that rain in my office? It's on the ceiling, but y'all don't hear that, do y'all?
I hear a little, but not a lot.
You hear a little bit? Okay. Yeah, I can hear it from this vent. All right, now for the last thing we're gonna do, and we're not gonna finish this part, but we have about 13 minutes or so to figure it out. Well, yeah, we'll get there. Not 13 minutes, but about 5 minutes. Let's just say that. Find the inverse of a one-to-one function. We're going to change f of x to y, if not already. We're going to interchange x and y. We're going to solve for y, and we're going to write this notation right here. What is this notation again?
Inverse function.
Inverse
Inverse.
function. All right, inverse function. Yep. Let's say it like that, because I'm tempted to say f of -1. All right. So in this little section, I'm going to show you, if I gave you, let's say if I gave you f of x equals 4x minus 7, how, and I say, what is its inverse function? I want you to sort of somehow figure out that it's this. And let me show a little trick to this. You all been dealing with inverse functions since middle school. For example, what's the inverse of addition? Anyone?
Subtraction.
Very good. Subtraction. What's the inverse of multiplication?
Division.
Division. You've been doing it since middle school. All right. For example, let's look at this right here. You got a -7 over here. And what do you have over here?
Plus
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 7.
+7. Look at that. And then you have a 4 times x. Y'all see that? And then what do you have over here?
Divided by 4.
Divided by 4.
You make that sandwich? Can you hear me?
Now that's not going to be as simple all the time, but sometimes you're going to be able to tell they are inverses of each other. All right. But just in case, we got a foolproof plan right here. These are the steps to change a function, well, to find a function's inverse. Here's an example. We have the first step, change f of x to y. So we did that right here already. Y equals 6x minus 12. What's the second step? Interchange x and y. Y'all see how the y changed to an x and the x changed to a y. All right. So now it's x equals 6y minus 12. That's why I emphasized that a lot earlier, to flip the x and y. Flip the x and y. All right. Next, third step, solve for y. All right. Tell me right after this step right here, what would you do to get y by itself?
Add the 12.
Very nice. Add 12 to both sides. All right. That cancels this out, right? And that's why you end up with x plus 12 equals 6y. What's the next step? What's the next step? How do you get y by itself?
And you got to divide by 6.
Divide by 6. That's why you get x plus 12 over 6 equals y. The last step is to just change that y to the inverse function notation. F inverse or inverse function, the inverse function equals x plus 12 over 6. Or how do they end up getting, why is this the same as this?
Because
Can
they
y'all,
divided it by 6.
okay. You divided what by 6?
The x plus 12.
All right. So here, this means x over 6 plus 12 over 6. All right. X over 6, y'all see that's an understood 1 right here in front of the x, right? So that's where the 1 over 6x comes from. And 12 divided by 6 is 2. All right. So whenever there's an or, though, I would take this one or this one. Both mean the same thing. All right. So either or. But I want y'all to know how to break things down just in case you see it somewhere. And you're like, I don't have that answer. I don't want you to think your answer is wrong. It may not have been broken down in another way, in another format. So we're going to try one of these before we go. f of x equals negative 3x plus 6. Tell me the steps for this first problem right here. Tell me
You
the first
change
step.
f of x to y.
Change f of
All right.
to y.
Very good. So someone else tell me, what should I write down first? What should I write down then?
Y equals negative 3x plus 6.
Y equals negative 3x plus 6 is correct. All right, someone else tell me, what should we do next?
You change the places of the y and the x.
Very good.
Switch them.
Someone other than Nakiria and Kenneth tell me what to write.
Do
X
is
equals
equal to
negative 3y
3y
plus
plus 6.
Very good. Y'all both right. All right. Someone tell me, what's the next step?
Subtract 6 from each side.
Divide by
Because
3. Divide by
what are
negative.
we trying to do? What are we trying to do right now?
Get y
Get
by
y
itself.
so
Get y by itself.
You're gonna
So
do
yes, we are subtracting 6 from both sides. All right. So now it's going to be x minus 6 equals negative 3y. We don't have y by itself exactly, so what do we have to do now?
You have to divide.
Divide
by
negative
negative 6 for negative 3.
Negative 3.
Negative
by
3.
negative 3.
Negative 3. All right, that cancels that out. Now we have y equals what? I'm going to put y first. What do we have?
X minus 6 over negative 3.
We
You can
we
divide
can't leave
that.
that negative down there. So what are we going to do with the negative?
X
You're
plus
going to
2.
divide it, so it'll be, yeah.
All right, here we go. You can't leave this down here. All right, so you either move it up like so in the numerator, or I think Zoe said something about she was trying to divide. But if you divide, it's going to be negative 1/3 x plus 2. That's another way to write. There's several ways to write this answer. But this will work, or this will work.